So it's okay, right? Am I audible?
Yes, sir.
Okay, good. So let's start. Yes. So here in the first slide, whatever you can see here, uh, just I would like to summarize this, like some kind of images. So in the middle, this one is a tumor cell. Okay, just a tumor cell, and those small light blue colored cells, those are called T cells. Like I'm just writing here T cells. This is like a particular population of our immune system. Those are cells which belong to our immune system. They are kind of a primary cell. They help in our in host defense. So those are the T cells, and this is tumor cells. Okay, this is nothing but just we are showing so that our immune system, they do lot of different stuff, including taking care of tumor growth as well as taking care of infection, all other types of diseases. So let's see. Human diseases, there are different categories of diseases. So here you can see the first one, I put here infection, which can be caused by bacteria, virus, fungus, and some other organism can be there. But all those things, they actually like they cause some infection, and those diseases are called infectious diseases. Okay, and next one, autoimmune disease. Autoimmune disease means this is a failure of our immune system. So that means our immune system, they have some assigned job, that if something coming from foreign, that means not our own body things, not our own things, then they should clear those things. But sometimes our immune system fail to understand which one is self and which one is foreign. If that discrimination is not there or some problem there, then it may arise autoimmune disease. Autoimmune, that means our own immune system causing some kind of problem, right? And the third one is immunodeficiency. So in that case, what happened? Uh, Maybe someone individual, like in that case, immune system is lacking some component. So as a result of that, it cannot take care of everything properly. Those that is called immunodeficiency. And the last one we have categorized as cancer. That is a problematic scenario. In the previous class also I told that there are many known and unknown reasons. So it's little difficult, or I would say challenging, for us to understand, for us to discuss, and for our immune system also, because many cancer, they can evade our immune system in such a way so that immune system cannot take care of those things. That's why it's a little bit problematic, like area. So anyway, if we briefly discuss about those diseases, that will take like much more time. Rather, we will concentrate on our immune system, and from the immune system perspective, we will see how we can tackle this thing. So first of all, this is, I would say, a little bit, history of immunology. So this is the beginning. And as I just started, so just, little bit of background. So Edward Jenner, considered as a father of immunology. So here I will tell you some kind of nice story. So you should listen that, and then you will understand the concept of vaccine. The concept of vaccination is very old, like not very something new actually. So in 15th century, so dried crusts from smallpox were either inhaled or inserted into small cuts in the skin. So let me, leave this slide. It's better to tell you the story. So what happened? Smallpox. Have you heard about smallpox?
Yes, sir.
Yeah. So chicken pox is very common. Whatever pox we actually get nowadays, that is called chicken pox. Okay. That is not severe. I would say it's okay. Like you can take care of its own. But smallpox was a lethal disease. It was there. And in 1979 or 1980s, that is present in slide actually, who the World Health Organization declared that there is no smallpox. And as a result of that, you guys actually, all of you, you actually born after 1980s. So you don't have vaccine for like, smallpox because it has been already eradicated. But I have actually, I have taken smallpox vaccine, right? So now, since the disease is eradicated, then there is no need for this vaccine anymore, right? But the disease was lethal. But the backdrop is, I would like to tell you the story that Edward Jenner and how vaccination started. So even in like I would say 15th century, what happened if someone suffered from smallpox, like after pox when it dried, like the dried crust, if that crust can be inhaled by someone or it can be inserted under the skin, then those person or those population can be protected from the disease. That was a outstanding observation at that time, and people used to do that. Now, but those are actually happening, but only Edward Jenner, after 100 or 200 years later, Edward Jenner actually scientifically did some experiment and actually proved the concept. And what he observed, that person who are used to milking cows, okay, again I'm telling you, persons who are used to milking cows, they are not getting this disease, smallpox. That is, or that was his observation. And many other actually knew, but he scientifically actually did all those things. But now the question is, why those person who used to milking cows, they are not getting smallpox? That's the question. So that means, you know, like something like smallpox, cow, they also had, or they also had cowpox. And some of these diseases, if the causing or the causative organism is very similar, they can protect, or they might have some kind of cross reactivity. That means when those population or those people are used to milking cows, they also get some cowpox. As a result of that, those cowpox actually protecting smallpox, and that's why they are actually protected from smallpox. So that was very I would say outstanding observation. And then he actually proved that he used to vaccinate that way, and finally the concept of vaccination actually started from there. The vaccination, the term, how it arises, if you see, because I believe all of you know vaccination, but if you see here, this one, right? So VACCA. So this is in Latin, that means cow. Okay. So since this cowpox and milking cow, from that story it has been started. So vacca means cow in Latin, and from there this term vaccination started. And later on, more scientifically, Louis Pasteur, so he hypothesized that weakened strain of some organism could be administered to protect from the specific strain causing disease. Okay, so in this case, for example, cowpox, that cannot create problem or that cannot create disease in human individual, but that can protect from specific strain causing disease. That means it can actually protect smallpox. So that way, actually, the concept of vaccination, I would say, started. And also, I would like to mention here, the vaccination is one of the greatest thing that can actually really protect people. Because if when you were small, you have taken a lot of different vaccine, booster dose, and so many so many vaccines. Those are really good. I would say that is, I would say, one of the best discovery in medical science, the vaccination. Because if you see other drug, they have a lot of side effect also. And antibiotics are also another one, like apart from vaccine, antibiotics are another class of, like, life-saving drug, I would say. But the thing is, improper use, random use of antibiotic nowadays creating more antibiotic resistance and other problem. But both of them, they are actually a major thing in modern medicine. Here in this curve, you can see the smallpox. As I just discussed about smallpox. Smallpox officially eradicated in 1980. So in this diagram, you can see in the x-axis it's mentioned year, and in the y-axis number of countries with one or more cases per month. So as you can see, in 1965, almost 30 different countries, they reported smallpox. And after 1975, it is getting reduced. As far as I can remember, last reported in 1977, although these figures say 1976. So 1976, 1977, during that time, it was last reported. And finally, smallpox, who declared that smallpox has been eradicated. And here I would like to mention another important thing. You don't need to remember that, but it's better to know that smallpox is a very lethal organism, but it has been eradicated. But actually the stock of this virus, the actual virus, actually present in two different locations. Just preserve it, because if similar thing happen in future or some outbreak happen, then people can quickly make I would say vaccine against that, or they can take care of it. So one has been stored in United States CDC, and the another one is state Russian some viral center, so in Russia. So in both lab, actually the origin, actual strain of this smallpox has been preserved. So, but you can understand this is very important to keep it safely, because it is a really, really lethal disease. Okay, not like SARS-CoV-2, I would say. It's even much more lethal. And as a result of that, it is everyone's responsibility to keep it safe. Like, so I just mentioned this, that those are already there, and they are just preserving those two.
Excuse me, sir.
Yes.
Sir, why is there a peak from 1970 in the number of cases?
1 minute, I'm just checking. 1970, this one.
Yes, sir.
Yeah, this is peak means this is not a number of patients. This is number of countries. Like here also, if you see the y-axis, I think just 2-3 more countries are reported. That's why. But this is not the number of patients suffering, because this is just number of countries. Okay. So for example, as far as I know, I heard from senior person, even from our family actually, that during 1960-65, during that time, many people actually died because of smallpox in our country itself, right? Many people actually. That is very much contagious. The problem is, if some family, the smallpox actually happened, like many people used to pass away. But the problem is, people are aware about this. It's really contagious, so people, they don't even move if someone actually have this family completely isolated, and that way it can be contained, but still it's a dangerous disease. Now, the immune system, the body's defense mechanism. So when I actually, say that liver, kidney, those are actually organ system. That means they are some specific organ, they have some specific function also. But immune system is not an organ system. It is a functional system. immune system is actually distributed throughout our bodies, and it is a complex system that encompasses every organ and compartment of the body. The main objective of our immune system is seek, identify, and kill invaders. That's why I told that foreign thing, not our own thing, right? And our immune system is highly adaptable. It can act against pathogen ranging from 30 nanometer to 100 centimeter. Can any one of you give some example of 30 nanometer pathogen and 100 centimeter pathogen? Just try. For example, first thing, 30 nanometer. What pathogen can be 30 nanometer? I discussed.
Virus.
Yes, virus. In last class, I told, right? Virus, because virus can be like from around say 20 nanometer to 200 nanometer in that range. And what about 100 centimeter pathogen? Just apply your common knowledge, you will get it.
Parasites.
Huh?
Parasites.
Yeah, parasites, some parasites. Say, for example, I would say some worm, even tapeworm, right? Those are also pathogen. So that has to be taken care by our immune system as well, right? So some of those worms, they are really, really big, and that can be in the centimeter range. But that's why I'm telling you that our immune system can take care like very minute, something like virus, which can be seen only by electron microscope, or something which is around say 100 centimeter range, like some nematodes, some worm, those things. So as a result of that, it is adaptable and it has different types of mechanism. And the last but not the least, this is the most important, that it distinguishes between self and foreign and mount response to only foreign while preserving self. If this discrimination is gone, then someone will get autoimmune disease because that person's immune system cannot understand which one is self and which one is foreign. Okay. So here, I just told you that immune system is a functional system, not an organ system, and a very complex system that includes skin. This is also some kind of physical barrier. You can include skin within the immune system also. Otherwise, without skin, everything can be infected very quickly. Lining of mucous membrane, those are physical barriers, some secretion, blood cells, bone marrow. There are so many things. As I will discuss, you will get all those things in appropriate place. So here, I'm not going through it. So now, from here, something will be started that you need to understand properly, that our immune system generates almost infinite variety of cells and substances. This is very important because see, we have our immune system, but today you are actually seeing some organism, some virus, some bacteria here, and your immune system is taking care of taking care of those things. That's why you are healthy. But now you are moving from here to some other part of the world. Maybe you went to, some other, like you are going to Australia or Africa, somewhere where some other set of organism present there, some other types of fungus, bacteria that might be present there. But still your immune system can take care of it. So your immune system can make product, and those product can be of infinite number. So you have lot of different stuff that can make so that you can be healthy, right? That's the idea. Now in this class you will understand that how those things are getting generated, what's the underlying mechanism, right? So let's see. So the primary objective of immune system is foreign recognition and the preserving self. We are not discussing the preserving self. That means how that can preserve our own thing. I would say that is even more complex to understand. And See, the first thing is foreign recognition. Now, immune system, they have two different types of response. One is called effector response. That means to eliminate or neutralize foreign particle. Here, particle means, we just put particle, but you can consider those like virus, bacteria, anything, even pathogen. So to eliminate or neutralize foreign particle or foreign thing, that is effector response. So that that organism can be cleared and someone can be healthy. And what is memory? Memory means while this effector response is going on, that means while the fight against the pathogen is going on in our body, who is taking care of this thing or who is involved in this fight? Our immune system, right? So during that time, some kind of memory is being formed. This memory is not the neuronal memory we are talking about. This is immunological memory, right? So as a result of that, upon second exposure, if the same organism or same pathogen again attack us, during that time, it will make enhanced response. So that time you will not get the disease. Your immune system already aware that how to tackle this pathogen. So quickly it will take care of it. So now under this, we can actually put two different thing here. One is called active immunity. So after this slide, I will actually take some break. Break means I will ask you some question actually, if you have. So active immunity. So immunity that will generate long-term memory. So for example, how you will get some long-term memory? See, when a person becomes infected by a disease, the body builds immunity against the disease. This is the natural way to make the memory, so that next time if you get the exactly same disease, you shouldn't get not disease. If you get the same pathogen, you are infected by same pathogen, you will not get the disease, but your immune system is already aware, so it will clear the pathogen. And the second category is a person can build a resistance to a disease following vaccination. So this is the artificial one, right? In case of natural, you are getting infected by some pathogen. So as a result of that, your immune system learn how to tackle that pathogen. In case of artificial thing, you need to take vaccine, like newborn baby, all of you know that they have particular schedule and they are taking many vaccines just to protect them. Okay. And as an adult, like normally you guys get a tetanus vaccine, right? When someone gets some cut by some, rusty metal thing or something, we take some tetanus vaccine. And also now people are taking this COVID-19 vaccine. So this is just to avoid the disease and try to build the resistance without the disease. This is vaccination or artificial immunity we are providing. Now, the question is another type of immunity is there. That cannot stay for a long time. That is for short time. That is called passive immunity. This is active immunity, and now I'm going to say about passive immunity. For example, when an infant receives mother's antibodies, that is natural but passive immunity. Now, I would like to clarify this thing, that infant receives mother antibody means infant, they are still actually taking milk from their mother, right? Milk also secrete lot of antibodies, right? So in a normal scenario, what happened? Mother and the baby, they are together, right? They are staying in the same place. So as a result of that, you can assume that whatever the pathogen around everything, they are almost facing the same thing. So as a result of that, what happened? Some of those antibodies which are generated, in mother, that can pass through milk, and that is also giving some kind of resistance to the inborn, infant or the newborn baby, right? That is some kind of passive immunity. That is one example. Another example is some kind of antibody, like immunoglobulin, is being injected to tackle snake bite. right? So if the snake is known that what kind of snake had bitten, and the thing is, some antibody mediated treatment, some like antibodies are available so that that can neutralize or that can act against snake venom. So as a result of that, that will actually destroy the effect of snake venom. So that is another example of passive immunity. So I hope that you understand that one way I told that effector function, that means how to remove or neutralize that pathogen. And the other thing is getting some memory so that in future you can protect yourself. And there are two types of this kind of memory. One is coming from active immunity, that is either getting the disease or via vaccination. And the another one is passive immunity. It cannot last for a long time, but for a short time, it will give you some kind of protection. As I gave you some example, like newborn baby taking milk from their mother, or someone like after snake bite they are receiving some antibody against the snake venom. So that's all. And then in the next slide I will discuss about more about immune system. So if you have any question here, you can ask me.
Sir, why does passive memory create any means if we inject antibodies, why does it create memory in the first place?
So here, Rajas, very good. Actually, this is confusing. I expected this question. So I would say this is not that way memory. You are actually right. When we are giving vaccine, that is actually teaching our immune system, or when you are getting, infection, that way our immune system is being, they can learn. But in this case, passive immunity, whatever, this is not really related to memory. This, I would say, little bit of confusion there, confusing information here. This is, but this is not like drug. So this is when you are taking some antibody, like some antibody treatment, that antibody can be there in that person in the blood for few days. Okay, so that is also giving protection. For example, I'm telling you in case of newborn baby, when that baby is taking milk from their mother, so then what happened? That antibody will be there actually few days. So that is also some kind of, this is not, you are right, this is not memory, that baby's immune system is not learning those things, but they have those antibody, and so that even after 2-3 days or some kind of similar pathogen attack, they can still take care of it because those antibodies are already there. That way it's kind of short-term memory, but this is not real memory. At the end of this class, you will you will know actually how this immunological memory form. So I will discuss that to some extent. So two modes of immunity, or our immune system work, mostly two different interconnected system. So one is called innate immunity. So the innate term, it means it's coming from birth, it's inborn. So that means that immunity or that protection is coming from birth. So whenever someone uh, after just after their birth, they have this kind of protection, innate immunity. And adaptive immunity acquired, that means some of our immune cells, they actually learn throughout the lifespan. That is acquired immunity. Okay, so I will discuss about these two things. So this slide, actually very carefully listen. This slide summarizes, although I will discuss about more details about innate and adaptive immune system, but in this slide you will get the overall idea about innate and adaptive immune system, or how we defend ourselves. So again, I'm telling you, innate means inborn, adaptive means acquired immune system, but those two systems are interconnected. You cannot see them completely in a different way. Say why I'm telling you, without innate system, the adaptive immune system will not be activated. So they are connected. So let me explain this figure, then you will understand the overall concept. This is a human individual, right? And if you consider those are bacteria, some pathogen, okay? Now this bacteria, they are attacking this human. Then what will happen? The human or the immune system present in this individual that will defend this person, right? Or they will try to destroy those bacteria. So the initial defense mechanism or the start at the starting point, like whatever protection we have, that is innate immunity, and that should act against those pathogen in a rapid way, and it will halt infection in most cases, but it cannot completely clear the infection, but it will slow down the infection and no memory. Why no memory? I'm telling you again. Say, for example, if this is only innate immune system is present in some individual, that is not possible in practical cases. But in theoretical case, if you consider that someone only containing innate immune system, then what will happen? If the same bacteria again attack this person 1 year later, 5 years later, then this individual will respond to that bacteria again in the same way. So that's why we are telling that no memory. That means it cannot recognize that this bacteria attacked previously also. That is not possible to know by innate immune system. Okay, so those are the three major major point, that its action is rapid and it halts infection and there is no memory. While our innate immune system, that means we have some components in our body, those are actually part of our innate immune system. They somehow try to actually halt this infection. And during that time, our adaptive immune system slowly take care of this thing. That means if you see in the second phase here, the bacteria, they are still present, but somehow this individual is trying to protect. But in the meantime, our adaptive immune components, although they are slower, but finally they will clear the infection and it will have some kind of memory, so that even after 5 years, 10 years, sometime 20 years later, if the same pathogen, that means if same bacteria, they attack this individual, quickly those memory immune cell, they will identify or they will understand, okay, this is the bacteria which I have seen before. So quickly they will make antibody and they can clear the infection, right? So the three major points are: the action is slow but steady, definitely, clear infection, and it has memory. Okay, so now I would like to just mention you, like if you consider in a different way, just to remember, like for example, in every country, if you consider in our case, so in India, like we have BSF, Border Security Force. So they are actually present in the border region mostly, and they are foot soldier maybe. So whenever some intruder coming from other countries, right, with some bad intention, what they will do? This foot soldier or this BSF, those security person, they will kill those, right? The thing is, they have to do the same thing again and again, and they will, whatever they're coming, they will do the same thing, they will kill it. But the thing is, only thing, if you can, if you would like to take care it in a defined way, then your, like, the country's intelligence system, that should work in a proper way so that it can be properly stopped, right? So this intelligence system, that is your adaptive immune system. So it is actually providing some more information to our bodies, to our immune system, so that it will learn how to tackle those things properly. Okay, so that way our body actually, our adaptive immune system actually help us, how to clear this infection completely. Here I would like to mention that, innate immunity, it is very rapid, But adaptive immune system after, I would say, after 5 to 6 days, like almost it takes around say 7 to 8 days so that your adaptive immune system can learn how to tackle this pathogen, and then it will make antibody and it will clear the infection. And for their contribution about innate immunity as well as adaptive immunity in 2011, like a group of scientists, they got Nobel Prize in physiology and medicine. Okay. This is overview of innate and adaptive immune system. But now specifically I will emphasize on innate as well as adaptive immune system. So this innate and adaptive immune system, those things you have studied before, or you are studying new now?
We had it in class 10 in ICSE syllabus.
Okay, okay. To some extent you are aware then, right?
By a different name.
Okay, okay. So now here this is one I would say little bit complex, but don't read here and there. The same slide you will see again and again, at least 1 or 2 more places. But I will explain here once, and then again after discussing some of those immunological things, then again I will explain this. That way you will understand. This is actually like lot of understanding here in this slide. So let's see. Here we are trying to compare the innate and adaptive immune system. In the x-axis, this is duration of infection. You can say this is in terms of days. This is 0 days. This is, you can say 1, 2, that way. For example, this is 10 days. This is not, very much fixed. This depends on particular, a human individual, and also it depends on what kind of pathogen the immune system dealing with. So there is no specific rule, but in general, it can be the scale from 0 to 10 days or 0 to 8 days, something like that. And in the y-axis, so I would like to mention here, this is not like your physics or mathematics, not absolute thing here, because it depends on what kind of pathogen you are taking care of, what kind of individual, how healthy that individual is. Those things are variable actually. So, but the overall mechanism should be similar. So now in the y-axis, this is the level of pathogen, that is also called microorganism. So level of pathogen, you can consider bacteria, virus, whatever you like. So now this slide I will take more time, but just try to understand what we are discussing. So here, this is the entry of our microorganism. That means someone infected with some pathogen, and that is being considered as 0 day, or the first day here, 0 day actually. Now what will happen? If this is bacteria, I told you several times in different class that if bacteria, they get suitable environment, it can divide very rapidly, right? So you can see here, when bacteria enter into our body, initially it will take some time, right? And then the number of bacteria or the pathogen microorganism, it is actually growing. See, it is growing like this. The number of pathogen in the y-axis, already I told that number of or level of microorganism, that means number of pathogen, it is growing like this. Right. So the thing is, initially first day, or I would say like few hours to 1 or 2 days, this is establishment of infection. That means this bacteria or other pathogen, they are establishing themselves in the host and they are growing in number. The induction phase, that means now that pathogen now know how to grow inside the host. It's kind of quickly dividing and the number of microorganisms getting increased very rapidly. If you see during that period, actually our innate immune system is taking care of this thing. innate immune system actually halt, like they try to slow this infection. Otherwise, it will go like this. It will go like this. But somehow our innate immune system is trying to take care of it. In the meantime, so this yellow here, little like light yellow, this is immune response, innate immune response. From the beginning, it is very high level, and then slowly innate immune system is not sufficient to prevent this, to protect us from this pathogen. Slowly, the adaptive immune response is taking place here, or taking care of it. And then you will see that when adaptive immune system is also taking care of this thing, like both innate and adaptive, both actually taking care of this thing, then this pathogen, they are not growing in number. Okay, somehow they are constant in our body. And finally, adaptive immune system learn how to tackle this. That means mostly they actually made antibody by that time, and slowly you can see the number of pathogen is going down, and finally you will see around 8 to 10 day, no more pathogen, and you are completely cured. And then some of those immune cell, like many immune cell took, are participated in this battle, and most of them, they have no function anymore. They will die. Those immune system, they have, the infection is getting cleared. But some of those cells who actually participated in this battle means with the fighting with this this pathogen, some of them, they will stay within our immune system for long time, long years. Those are called memory cells, memory immune cells. After several years, again, if the same pathogen attack us, those memory cell will quickly understand what is this pathogen, without even involvement of our innate immune system. Very quickly, they will understand that what is this pathogen, and they will quickly make antibody against that pathogen. So as a result of that, next time you will not get the disease, right? So that's why you are being protected. Here I would like to mention you, many of us, many of you used to get very very common, common cold, a little bit of fever very often. Nowadays, if someone of us, we get some fever, we are very much nervous and doing so many things. But if you see 2 years back, this is normal, right? What happened? In most cases, if you are healthy enough, without medicine or with medicine, you will see after 5 to 6 days, you are completely fine. Right? You suffered a little bit, then after 5, 6, 7 days, completely you are fine. Why? Because of initially your innate immune system was taking care of that, but it failed to do so. You get the disease. If innate immune system can also clear this thing, then you will not get the disease. But now, since it failed, but it's somehow protected, or it gives you some time so that your adaptive immune system can take care of it. So you are getting some disease symptoms, that after 5th or 6th day, you are actually getting better. And finally, after 1 week, you will be finally fine, because your adaptive immune system completely taken care of this infection or disease. So that's why, as I told you, for most of the cases, like common cold, like small fever, or all those things, without medicine or with medicine, you will see that 5 to 6 days, it's fine for us, and you will be completely cured, right? So that way, our actually innate and adaptive immune system, they both of them, they work together, and finally they make us healthy. And here, how adaptive immune system actually learn that what kind of pathogen there, how to tackle it, that clue or that information is being provided by our innate immune component. Innate immune system initially fighting, right, against the pathogen. During that fight, they are giving the clue, they are giving the hint, some kind of signature motive of that pathogen to our adaptive immune system, so that they can make weapon against that pathogen. That is the overall concept of both innate and adaptive immune system.
So, in
Yeah.
this last half sir, in the last half, like the adaptive immune system is responding, but along with that, the innate immune response is also responding, right? Or the
Yeah.
innate one stops acting.
Yeah, so I would say, Tanmay, that innate is also there, but during that time when you are already getting the disease, say for example, if I'm saying about some like viral fever, like not viral fever. So after like 3-4 days, when we have fever, that means that virus is already there actually. Now innate system alone cannot take care of it. So here in this figure, that means here this innate immune response is getting narrow here. That means that doesn't mean that our innate cells are not working. I would say this is the contribution of innate immune response is getting low now. Now mostly adaptive immune system is taking care of this battle, right? It doesn't mean that we don't have innate immune response or innate immune component. This is just meaning that here in this part, the contribution of innate immune response is much lower compared to the adaptive immune response. Is it clear, Tanmay?
Yes, sir.
Yeah.
Excuse me, sir. Hello.
Yes.
Sir, is the adaptive immune response getting activated in the inductive phase?
Adaptive one is activated. Yeah. So if you see inductive, like again, like I started this slide that way, there is no hard and fast rule, but this is overall thing because it will depend on what kind of organism you are talking about, the particular individual's health, the host health, all those things are important. But here you can see here inductive phase means here the adaptive immune system, they just slowly getting. So why? Because of thing I didn't discuss that. That's why I'm telling you again. I will come to this slide later. Then you will understand that after little bit of fight with those pathogen, with our innate immune system, then only adaptive immune system will try to understand. From the beginning, it will not like, it cannot understand what kind of pathogen is this. So let me go through it, then you will get this point, why the initial battle is required between the pathogen and our innate immune component. Okay, you will get those points completely. Now, I will ask one question actually. Try to answer my question, okay? If we actually develop some mouse in lab, right? We cannot develop human in that way. That's why I'm saying mouse. That one type of mouse, they have only innate immune system, but no adaptive immune system. And another category of mouse, they have only adaptive immune system, but not innate. So here I would like to mention you that I told you that skin is also part of our immune system and skin should be part of our innate immune system, but don't consider that mouse without skin, that is not possible. But mostly the innate system is missing in some mouse, okay? And other group of mouse, they don't have the adaptive immune response. What do you think? Which group of mouse will be more susceptible, or which group will survive longer?
Innate.
Adaptive.
sir.
Adaptive one.
The innate immunity.
So three students actually answered this. I will ask them actually properly because it's a little bit confusing. So Rajas, Viswanathan, and Tanmay. So Rajas, so you told innate. So so that means you are saying that mouse without innate will survive more.
No, mouse with innate.
Okay, mouse with only innate, they will survive more. Okay. AK Viswanathan.
Sir,
Yeah, if you can try. It's okay. If you are not trying, that is also fine actually. So the thing is, if you see the curve, so I'm going here.
So, one question. So the
Yeah.
innate immune response is there from the beginning, but as soon as the infection starts increasing to a certain level, it will start kicking in the adaptive immune response automatically. Like
Hmm.
so, even if we like, what does it mean when we when we say that the adaptive immune system is removed?
Yeah, so Tanmay, so in this case, like, you cannot completely destroy innate immune system or adaptive immune system or mouse, but experimentally it is possible. You are taking, like, almost you are destroying most of the innate immune component in mouse, in one group of mouse. In the another group of mouse, most of the adaptive immune component, I didn't discuss what are the adaptive immune component. Later I will discuss. So if you destroy these two things in two defined group of mouse, then you will see this kind of result. Let me show the result and we will discuss this. See, this yellow curve here. So this is the same thing here. Only thing, this curve we are showing, not all these details, only this curve like we are showing here. This yellow curve here, again, the x-axis is duration of infection, y-axis is the load of pathogen. The yellow curve is the healthy mouse, right? And now the red one, the red curve is mouse lacking innate immune system. As I told you that innate immune system component, they actually initially try to prevent our, prevent those pathogen. If you don't have your innate immune system, that means those mouse, that means those pathogen will grow very quickly. And also, as I already told, without innate immune system, your adaptive immune system is also it will not be functional. So as a result of that, it will be very dangerous that someone without innate immune system, for example, this mouse, they have or they lack innate immunity, right? You cannot completely destroy innate immunity, but lacking innate immunity. And now, if someone containing or someone they lack adaptive immunity, then what happened? In the initial phase, innate immune system is taking care of that. Then finally, when in the healthy mouse, you can see that it's bell-shaped curve. So again, it is coming down the level of microorganism, right? But in this case, what you will see that it is not coming down because adaptive system is not taking care of it. So as a result of that, innate, whatever it can do, it has already done that, or it already completed its job. But finally, active immune system is not properly functional. So as a result of that, now again the number of microorganisms is getting higher in number, and it is not going down. So as a result of that, a mouse without or mouse lacking innate immunity will be more susceptible to disease. They will die soon, rather compared to mouse with or lacking adaptive immune system. So here the innate versus adaptive immunity, I'm not going into this slide anymore. Everything I have discussed in previous 3-4 slide. This is just for you to read. You can just go through it, and it is some information for you. So now quickly I will go through some portion of the innate immune system. Then we will take some break, and then we will start discussing about our adaptive immune system. Okay, so let's see. Innate immune system is much simpler, I would say, to actually explain in a brief way. So let us discuss about this. So innate immune system. So we have roughly we grouped into 3 different categories: mechanical, chemical, and biological factor. So apart from this, some innate immune cells are also there. I will also come into that. But this portion is much easy to understand. I will go quickly and you will go through it later. So mechanical factor, for example, as I told you, skin is some kind of barrier, and we have skin throughout our body, and it protects us. Where we don't have nice skin layer, there we have a lot of protective mechanisms. Say, for example,
तुम्हारे साथ गलत हुआ है, लेकिन अब जो भी होगा बिल्कुल सही होगा.
So for example, in our eye, we don't have skin layer we have, but it's also open. So in tear, we have some enzyme that can protect also in tear. And also in mouth, we have saliva, we have lysozyme that can also protect us to some extent. So as a result of that, mostly skin is a like good barrier, and as a result of that, it can protect us. And now mucus layer is also present inside our body, like for example in our respiratory system, in many other portion, and that mucus also help them to protect us. And flushing action of saliva and tears, as I already told, that is also some kind of mechanical factor. And if something like very small dust, small particle actually, it's going into your eye, then this flushing action that can clear these small things from your eye also. So those are the mechanical factor. Chemical factor, our sweat. Antimicrobial peptides are present in our sweat, and that actually protect from many, like microbes, protect us from many microbes. So this is the role of antimicrobial peptides. I'm not going into like in a lot of details here. Hydrochloric acid, or the acidity of stomach. So in this figure, you can see that gastric juice or gastric acid present in our stomach. And as a result of that, in our stomach, the pH is around in between 1 to 2, right? You can see here, we just mentioned here the lemon juice, the pH is 2, and then orange juice 3, tomato juice 4. All of you have very good understanding about pH, but what I want to say that our stomach is really, really acidic, and that is good. Why? Because see, when you are eating food, like you are eating many things, right? Sometimes you are eating pani puri, fuchka from outside, in many places you are eating so many things. But how many times you get the disease? Very rare. Like almost like I would say, if you are healthy, most of the time you are completely fine. Why? Because although you are taking a lot of microorganism and pathogens sometimes present in this street side food or whatever it is, but whenever they enter quickly into your stomach, the pH is 1, close to 1, just, unbelievable, right? So that will destroy almost everything. Only few pathogen, say for example, like one pathogen that cause, gastric ulcer, that is called Helicobacter pylori, some bacteria. So that is even that can resist this strong acidic condition also. But those are rare. So as a result of that, whatever you eat, something still present there, but finally it will be, destroyed in your stomach. So this is again part of your innate immune system. So, whatever we are eating, that should be destroyed. And here, as I told, that lysozyme is present in tears and saliva. So as a result of that, you can see here, this is, just funny image I put here, that I believe they are watching some really, horrible movie. So all of them, they are crying, but I mean to say that is not bad always. So in their tears, they have lysozyme that can also, protect them from eye infection. That means some, lysozyme can act against bacteria. All of you know, I actually discussed it sometime earlier. So as a result of that, lysozyme present in tear and saliva that can also protect against, protect us against bacteria, right? So those are the chemical factors. I'm giving some example like mechanical, like skin.
So just one
Yeah.
question.
Yeah.
So there is an eye disease called STY. So that is also an infection or just a normal?
Yeah. So STY on our eye, right? So STY is a bacterial infection. Okay. So initially, like 2 semesters back, I had the slide in this lecture actually. So you are asking about STY, right? STY, right?
Yes, sir.
Yeah, so that is actually some kind of bacterial infection actually. So mostly that happened not inside the eye actually, that in eyelid mostly actually happened, STY. Yeah. So most like
That is also taken care of like by the lysozymes.
so no, so this is mostly on the upper lid of this eye or the lower lid. So as a result of that, lysozyme cannot come contact, like lysozyme present inside actually, in the eye inside actually. So as a result of that, most of the time this sty can be cleared by its own after a few days, or you need to take some antibiotics. right? So that is very common treatment or antibiotic ointment. Even you don't need to take or consume antibiotic because this is very local infection. So you can take some ointment or some antibiotic. That should be fine. Okay. So, but STI is very common actually. It's not, nothing dangerous. It's fine. Hmm.
Sir,
Many of us.
query.
Yeah.
Yes, sir. Sir, is acid means pylori an acidobacter? Because
Yeah. Helicobacter pylori, they can actually sustain like lot of very high acidic conditions. Somehow still they survive. I like detail how actually the details of that, how it can actually prevent this. I'm not aware too much of those details, but yeah. So that's why Helicobacter infection is a problematic thing that can resist this high acid condition. Yes.
sure.
So now, next slide. So I told about mechanical, chemical, and this is the most important also, the biological factor. The normal,
Excuse me, sir. Just a
yes,
small question. If tears protect us, then why are they not secreted all the time?
yeah. So I would say, Rajas, that actually, always to some extent, secretion is going on. Otherwise, your eye will be completely dried. Okay. So the tears we are talking about, not only, that tears when someone is crying, that time it's mostly coming like, lot of tears coming. But in apart from that, constantly little amount of eye secretion tear is coming out, otherwise you cannot even see, cannot even read, it will be like dry eye. Actually you can see, I would say, if this kind of symptoms happen because of some small infection, sometime it happens, like one eye drop available, that is called tear drop. The name is itself tear drop. Okay, so actually little bit of tear is always coming out. Okay, and that is helpful and that is required because all the time we are actually saying something, our eyes open and closing, open and closing. When that is getting close, that time this small amount of tear getting actually circulated in whole eye, otherwise it will be dried, right? So that's why to minimum amount it's already there.
Yes, sir.
Yeah. So now the biological factor, this is very important. The normal flora means here bacteria. Like bacteria, sometimes people get classify is as, with plant kind of thing. So anyway, that you can forget. The normal microbes in many parts of our body. So mostly, from in the skin also we have a lot of bacteria, and it starts from nose, mouth, lungs, everywhere bacteria present, right? Everywhere. In stomach, not, mostly bacteria they are not present in that way because as I told you, but they are showing the whole digestive system here. Again, huge amount of bacteria present in our small intestine, large intestine, everywhere. And whether that is good or bad, that is actually good. Those bacteria we have in an healthy individual, we have more than 1,000 different types of bacteria, and those are the normal population, and we should have those bacteria. Otherwise, the problem is, if we don't have bacteria, then like pathogen, they will attack us very easily because these bacteria, they are sometime or they are actually posing some kind of challenge to those pathogen because those pathogen, they need to compete with this our good bacteria or commensals which are present in our body, right? Again, I'm telling you, we have like different types of bacteria, and in a different class, I told you the number of bacteria present in our body is more than our own cell number, right? Because bacteria are very small. So as a result of that, although they are present only in this location, like digestive system, skin, mouth, but still their number is higher than our own cells, and those are taking like important role, and because of them, because of this normal flora or normal microorganism, like bad thing or the bad element, I would say pathogen, they cannot quickly colonize and quickly infect us. And that is the reason I should mention that, not for exam, for your understanding, when you are taking broad spectrum antibiotics, generally you should take during that time or after that, you should take like little bit of precaution, because of that broad spectrum antibiotic, you are trying to destroy the pathogen or bacteria which actually causes the disease. But the thing is, the same way they are actually clearing, they are destroying our own good bacteria. So during that time, you should take proper amount of curd yogurt. So they contain lot of good bacteria, and that can help to re-establish our bacterial population in our gut, in our digestive system. And also nowadays, some bacillus spores are available in the medicine store. Even some doctors, they prescribe that some spore, like some, I would say those are actually good. So after take kind of, they will help you to re-establish your bacterial population, and that is required, and that will be that is sign of a good health. Okay. So, yeah. It's okay, right? So I'm going to the next slide. The innate immune system. I will discuss about 2 more slides, then I will take break. So we were talking about innate immune system, but if you see, whatever we have discussed, those are not directly immune cells, either skin or this kind of mechanical factor or some chemical secretion or some other bacteria which are present in our body, but they are helping us. But in this slide, what we are trying to say that innate immune system, that is cells of our immune system or cells of our innate immune system, cells of immune system that take part in innate immunity, right? Now, here you can see source of cellular components of the immune system, not just innate immune system. Many things written here. Okay, you don't need to remember those things, but you can just go through once, because I would like to tell you, like someone who is not attending class, they might try to remember all those things, but you don't need to remember, but go through it. Even many of those components you will find in your blood report. When you provide your blood for TCDC, like what stands for TCDC, total count and differential count. If someone is suffering from fever for a long time and many things happen, then your doctor
So
prescribes.
CBC is sometimes taken. That is also same as this.
Sorry, say again.
Sometimes the doctor tells the complete blood count CBC.
Yeah,
That's also same
yeah,
as this.
exactly. Yeah. So mostly we said TCDC, total count and differential count. In the differential count section, you will find multiple component like eosinophil, basophil, neutrophil. You will
Yes,
get all those, whatever the blood report. So all those things you will get this in slide also. So only thing, what during that time someone suffering for little longer time, the disease is not getting cured, doctor want to see that whether immune components are in right amount or not. If everything is right, most likely the person will be again cured within few days. If something is really wrong, then we need to take care little bit. We have to pay more attention there. So that is your total count and differential count. So see here, what are the major important thing? I'm not going to all those things, even you don't need to remember, but all those cells of our immune system, mostly those blood cells, they are coming from bone marrow. Remember it, never forget. In the bone, inside the bone, you have bone marrow. Those are actually stem cells. So the concept of stem cells, I didn't, discuss in details because this semester we didn't have that scope. Mostly in a different semester, like not online, different semester, we discuss about stem cells in a class. So for example, you have cells in your liver. From the liver cell, you cannot make kidney cells or other cells. I'm just giving some example. From eye cells, you cannot make other cells. So those cells are called fully differentiated cells. So they attend what cells they should be, and they have some particular function. But stem cells, they have the ability to make different types of cell. Those are the stem cells. They have the ability to make different types of cells based on the need, based on the requirement. So similarly, all of our immune cells, blood cells, they are getting generated from bone marrow. So that means the cells present inside the bone marrow, those are stem cells. They can actually differentiate, they can make different types of blood cells or immune cells in our body. So here you can see, as I told you, the top one is bone marrow, this is stem cell, and in the middle many things written here, just go through it. You will get platelet, you will get eosinophil, basophil, all these things you normally get in your differential count blood report. But here I will talk about some of those cells which I will discuss onward like in this class. So T cell, here you can see T cell, B cell, those are part of our immune or adaptive immune system, right? Now all of you are actually, many of you are aware about this T cell, B cell, so many things because of this COVID thing, COVID vaccine, because even in normal newspaper people are writing so many things. So B cell, T cell, they are contributing, they are mostly part of our adaptive immune system, and B cell makes antibodies, and together they work in our adaptive immune system. And some other cell, like you should remember only these four. Remember means to understand the concept of immune system, what I'm going to discuss. One is macrophage, and the other one is dendritic cell. Okay, immature or mature, forget about this at your level. So dendritic cell, macrophage, these two you have to remember, and you have to remember B cell and T cell. Okay. So
the dendritics, like it is related to the nerve.
No, though that is dendron, that is dendrites. That's a different thing. That axon and dendron, the term came because of this, if you see here how they look like. So in the nerve cell, so normally in school days you have you drawn nerve cell like this. Okay, I believe you something like this, right? So this is called axon, although I'm not discussing about neuron, and this is the dendrites means this projection here. So they have the similar thing here. So that's why they are called dendritic cell.
So because of the looks, they are named like that.
Exactly, dendritic cell. So macrophage and dendritic cell are part of our innate immune system, but they actually process some information and then they provide that information to our adaptive immune system so that our adaptive immune system can make antibody against that pathogen. I will repeat this part again. Dendritic cell and macrophage is actually, belong to our innate immune system, but they link innate and adaptive immune system both. So what happened when someone get infected with some pathogen, those dendritic cell or macrophage, they actually eat or engulf those pathogen. It can be bacteria, it can be virus. So whenever that virus and bacteria, they are going inside the dendritic cell or macrophage, they process that information. They actually destroy that virus or bacteria inside them, and they process those information. And finally, they actually, provide clue information to our adaptive immune system that, okay, this is the signature of this pathogen, make weapon against this motive so that you can win the battle. So I will discuss that in more details. Okay, so that way.
So you said that they get inside like the innate immune cells destroy the pathogens by engulfing them. So that is by phagocytosis they are destroyed.
Yes, definitely. I have slide also here, phagocytosis. But the thing is that here it's kind of, as I'm telling you, battle intentionally. That means, see, some skin cut happen here. Some bacteria enter inside the skin, and if that bacteria is pathogen, right? So pathogen means, causative organism for some disease. So now that bacteria, those bacterial population will multiply in this region. Some of our immune cells, mostly macrophage and dendritic cell, they will travel in this location. Immune cell, they can travel throughout our body. So they will travel here and they will start the battle here. So the function of dendritic cell and macrophage will be, engulf those pathogen and kill those things. But honestly, I would say the pathogen, their number is very high. They are small in size. So if these macrophage and dendritic cell can clear the infection quickly, you will not get the disease. Nothing you can see, almost, nothing there, almost normal. But if they cannot take care of it, many times happen, then what will happen? This dendritic cell and macrophage, they will process the information. Information means I'm not telling you intentionally here. So information means here, they will actually try to understand what kind of proteins present in those pathogen, and based on those information, they will process some information and provide that to T cell and B cell so that they can make antibody, so that those antibody can act directly against this pathogen. And when you have the antibody, like B cell, they can secrete million of antibody. So as a result of that, when you have antibody, you will that immune system will win the battle. So as a result of that, the disease will be cured, no more disease. But this detailed mechanism I'm going to discuss now, to some extent, whatever is possible in one class, right?
Sir.
Yeah.
Yes, sir. Sir, is that the same cells which does the phagocytosis also identify the diseases, or there is a other type of memory cells, means memory?
Yeah, other type of memory cell, because phagocytic cell, they don't have memory, macrophage, dendritic cell, they don't have memory. So all of you, many of you are asking very good questions. So you are listening properly, I understand. But let me go through it. So I will, whatever you ask question, this is very nice question, but you will get it when I will discuss, okay? But very interesting question you actually you are asking. So give me 2 minute break, okay? I will be back after 2 minutes.